Okay, so let's summarize what we saw there. So right now, our growth function, right, our exponential function, a is raised to some x power where a is greater than 1. And basically what we saw in terms of patterns and basic behaviors is when I go graph this function, right, the one thing for sure is that it's going through 0, 1. So it has a y-intercept using some previous knowledge that we have of 0, 1. And then in the positive x direction, the function eventually explodes, right? Goes upwards, heads towards positive infinity. And then in the negative x direction, it's going to just basically get closer and closer and closer to the x-axis, well, without ever really reaching it, right? And so we call that an asymptote, right? As a matter of fact, it's called a horizontal asymptote to be official. Okay, so a horizontal asymptote is the x-axis, or what we call y equals to 0. All right, and because it's getting closer and closer to it, right, that means that we never actually cross the x-axis. So that means there are none, right, x-intercepts. So we never cross it, so we never have an x-intercept. So that's something that's kind of unique to a exponential growth function. So it passes through 0, 1, y-intercept, but it never crosses the x-axis. It just gets closer and closer to it, right? In terms of some other language that we've learned in our class, right, as far as functions are concerned, we worry about their domain. Well, again, I know I just used from -1 to -2 and 1 to 2, but if we just kept with that pattern, right, we can put anything I want inside there. As a matter of fact, we even handled something like a to the 1/2 power, right? That would just be the square root of x, all right? And even a to the -1/3 power would be 1 over a to the 1/3 power, which is just a to the cube root of a. 1 over the cube root of a. So it basically handles all values of x that we can throw in there. So the domain is everything. The range, however, we are limited in terms of the range. As we noted, it's getting closer to the x-axis without ever touching it. And you'll notice that there's no part of the graph, right, that's underneath the x-axis. So what that basically means then is that the range is limited. The range is from 0 to infinity. Okay, so those are some special qualities about a exponential growth curve, right? It goes to positive infinity in the positive x direction, and it gets closer and closer to y equals to 0, right, in the negative x direction. And so there's more that we can say about this, but based off of some things that we've mentioned in our class and what we discuss, right, we've learned about intercepts, both x and y. We've learned about domain and range, right? And the new thing for here is the way this function behaves, as well as this idea of what an asymptote is. So some new information for us to consider. All right. And so as part of this wrap up too, I think I mentioned this. One of the most famous exponential growth functions is e to the x. E is roughly equal to 2 point, it's roughly like 2.718 or something like that. So it's definitely bigger than 1. So if we were going to graph e to the x, this graph would behave like all other exponential growth functions. And again, this turns out a lot when we're measuring population dynamics, when we're talking about money, heck, even to sound morbid here, the spread of a virus, right, or sickness. Basically, it starts off slowly, and then it starts to basically catch on like wildfire. And that's basically what we call exponential growth. Another famous exponential function is 10 to the x power. Essentially, this one is famous because we work in base 10. Right? Our number system is base 10, so raising 10 to a power kind of makes sense, right? And that also has some ramifications for other applications. But this guy is really famous. When we mathematically model many things in science, e to the x keeps rearing its head, right? So there's basically a summary of exponential growth, what the function behaves like, what its behaviors are in relation to some things we've learned in the past, this new idea of a horizontal asymptote, and some famous exponential growth functions. All right, so now we have some more exponential functions to learn, but I'm going to do that in another video coming soon.